video is going to be the first video of several on solving algebraic equations. The way to tell, obviously, is the 1, and the next video will be 2, etc., right? But this video, just to get some housekeeping out of the way, this video is only going to be about how to solve one-step algebra or algebraic equations using addition or subtraction, and that's it. Okay, the next one will be the one-step equations with using multiplication or division. Okay, and the third one will be multi-step problems instead of the one-step. It'll be the multi-step. The fourth one will be that'll be different. It'll be more abstract, a little bit more difficult. And I guess that's it. Okay, so anyway, addition and subtraction, one-step problems. If this is not the one for you, go to the next video or whatever. Okay. All right. So let me talk. I know I talk a lot, and I just want to, explain why I think algebra is difficult for many people, including myself when I first started learning it. Basically, I remember being in first grade, and they would teach us how to add, right, or add or subtract. And I remember my Miss Jaramillo, my first grade teacher, she brought in apples, and it was basically, what do we get when we add 3 apples plus 4 apples? And obviously, all the kids, we group them all together, put them in a big pile, and we count them. And we can actually touch them. 1 apple, 2 apple, 3 apple, 4 apple, right? And I think that's why algebra is difficult. We can't touch anything. It's all abstract. Abstract means like an idea or a thought that doesn't have a physical form. Okay? It's out there. It's an understanding. It's a mutual understanding. When I say 3, you understand that means 3 something, right? You're like thinking apples or fingers or, something like that. So anyway, algebra is very abstract. Nothing you can really touch. And so when we get to big complex equations, you just have to rely on your ability to follow the steps, follow the procedures. So these first 2 videos are going to be actually kind of easy in the sense that it's just one step. In fact, you're going to be able to see the problem and probably get the answer just by looking at it, because they're that direct or that obvious, I guess. I don't want to say easy, because for many people this is not easy. Anyway, so I was online and I was looking at a couple other teachers teach this concept, and what they like to do is they do this. A lot of people do this, and I think this is great. This is perfectly cool. I get it. It's like a teeter-totter, right? So what is an equation? An equation is when we have information on the left side, information on the right side of an equal sign. Okay? So what does that mean? Well, the equal sign is there to show that both sides are balanced. Okay? They're balanced. They weigh the same, or they have the same value. If you could imagine maybe putting a quarter, like 25 cents in the form of a quarter, a U.S. quarter. The other side, maybe you could put 2 U.S. dimes and a nickel, right? 2 dimes and a nickel. That's 25 cents. The quarter is 25 cents. They have different forms. They don't look the same, but they equal the same. Okay? So that's basically what an equation is. And this is why you always hear teachers or tutors or whoever's teaching you this, they always say what you do to one side of the equation, you got to do to the other side of the equation. So for example, and the reason why we have to do the same thing to both sides of the equal sign is because of the equal sign. Equals means it's equal, and we can't change that. All right, we can't change the fact that it's equal. So we have something on this side that weighs, let's say, 5 pounds. The other side also weighs 5 pounds. And if I take away 3 pounds off of this one, it gets out of balance. And so I have to do the same thing over here, take off 3 pounds one way or another, so that I bring it back to equal. Because that's the one thing we can't change. We can do whatever we want to this side, and we can do whatever we want to this side, but the one thing we cannot change is the equal. We have to maintain balance the entire time. And later on, we're going to see inequalities. And inequalities, they start off like this. And that's okay. And we got to do all these steps, but we have to maintain that perfect inequality or that unbalance all the way through. Sorry about that. Let me just turn that off. Okay, so that's what an equation is. That's what I would say what it is. The next thing is why. What's the purpose? What are we doing here? Why? Right? Why do I have to do this? Well, I'm not sure why you have to do it, but what we're trying to do when we're solving equations is we're trying to find the value of x. And x is just a letter, okay? It's just a letter that takes, it's what's called a variable. And it just takes the place of an unknown number. And we're trying to find that number. But because we don't know it, we just put a value of x. Well, it's something, so we use x. It can be any letter, you know. Usually I was taught with x all the time, but it can be p, it can be s, it can be any letter of the alphabet. It's just a letter that takes the place of an unknown number. Now, the way we do this is we try to get x isolated, or get x all by itself on one side of the equal sign. Because when we do that, we're exposing it. We're saying x, you're all alone now. You can't hide behind all the other numbers and terms. You're all alone. So what are you? You know, and it says, oh, well, okay, I'm equal to this number, this amount. And that's what we're trying to do. Now, to isolate x, we have to go back to what we learned about how to group like terms or how to simplify. Okay? So it's really called simplifying, but simplification can mean different things. Usually it's grouping, sometimes it's distributive property or something like that, right? But it's just a term that we use to make something more simple. So remember, grouping is all grouping the same. That's like I use the example in the video on grouping or on simplifying. I use the example of a pile of money, coins. Again, I like money, right? A pile of coins, right? Nickels, dimes, quarters, pennies, all that stuff. And what we do is we separate. Well, all the quarters can go over here. All the nickels can go over here. And that's how we simplify. That's what grouping actually means. So anyway, we're going to get into this now, all right? So I would recommend maybe writing this down in your notebook or something. Just important concepts, okay? Now, remember, grouping or simplifying is adding and subtracting like terms. However, when we got to cross the equal sign, it's my eraser, when we cross the equal sign, we have to do an opposite operation. So in other words, when we have, when I talked about 5 pounds over here, 5 pounds over here, my head's the equal sign, we take away 3. Well, that's not the best way I want to describe it. Let's just get into it and see how it works out. Let's see how that works out. So anyway, opposite operations are these ones, at least so far for us. There will be, if you continue with your math career, these opposites just get bigger and bigger and more complex. But anyway, addition and subtraction are opposite, obviously. Multiplication and division are opposites. Hopefully that's obvious. This video, we're not going to be doing this one. We're just going to be focusing on the addition and subtraction, okay? So let me put a problem up here. I have the first one as 12 is equal to x plus 6. Okay, this is a one-step problem, and all these are going to be one-step problems. And remember that the one-step problem is the last step of a multi-step problem. That makes sense? So if you have a multi-step problem, bam, 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 you're doing all this work. Simplifying, grouping, simplifying, and then you're left with one more step. That could be here. That could be one of these, okay? So later on we'll do the multi-step. That would be video 3. But anyway, okay, so one step and we should be able to get to the end of this. We should be able to get to the answer. And actually I think a lot of you can probably just look at this and say, well, if 12 is equal to some number, remember that the variable takes the place of a number that we don't know, supposedly, right? But I think you guys can see it. It's a number plus 6, so that would be 6, right? 6 plus 6 is 12. And I have students that try to get in the habit of just guessing. They're like, I think it's going to be, and they solve it by just looking at the values, right? But we have to learn how to do a procedure. We need to know what we're actually doing, because the equations are going to get much more difficult in the sense that you're not going to be able just to say, well, that's going to be this. You can't do that. We need to learn the steps. So, I'm sorry, but we have to learn it the slow way. Okay, now the first thing I like to do is this. And I tell my students to draw a line where the equal sign is, because it maintains organization. Especially when we do very complex problems, you want to have things organized. I've seen students put equal sign here, and then they do a step, they simplify something, and then the equal sign ends up over here, and then ends up over here, and then you don't know what side's the right side or what side's the left side. And actually, that's actually very important. You do want to maintain left and right, very clear, okay? Okay, so, like I said earlier, it's based on opposite operations. Let's go back and think about simplifying, like terms. I have 3 terms here. I have a 12, an x, and a 6. Now, out of these three terms, two of them are considered like terms. And those two would be the 12 and the 6. They're just numbers. This is an x, so the x can't be grouped together with the 6 any other way than just adding it. Okay? What I mean is it's not like this, right? Like 6 times x. Right? It's not one of those kinds of things. That's later on, that'll be video 2. So right now I gotta say, well, I can group the 6 with the 12 or the 12 with the 6. But remember, the whole point of this is to isolate x. So x is on the right-hand side of this equal sign. I might as well just leave it there, right? And move the 6 over here to buddy up with the 12, right? But how do I do that? How do I move something across the equal sign? That's where this comes in. Opposite operation. So what is keeping the x and the 6 together? What's tying them together? Well, it's that addition sign. They're added. So, obviously, what am I going to do? I'm going to subtract. I'm going to subtract. And this will eliminate the 6. It totally comes off. But remember, back to that old thing that you always hear, what you do to one side, you got to do to the other, because the one thing we can't change is the equal sign. Okay, we just can't change it. So, what I did over here is subtract 6. I've seen students do this. I've seen that. Why do you think they do that? They do that because, well, I make that number into 0. That's what I did over there. So, remember, what I do to one side, I do to the other. Well, I made that value equal to 0, so I guess I got to make this one equal to 0. No. That's not what we're trying to do here. What we did, do I have another color somewhere around here? What we did was this. That's what we did. That was the operation that we did. And that's the operation we have to do over here to this side, okay? So, minus 6, okay? So, 12 minus 6, positive, negative numbers, remember that. That's a positive 12, it doesn't have a sign, it's positive. So, it's going to be positive 6. Maybe one suggestion is maybe be a little bit more nice or more neat than me. I would maybe rewrite the whole thing. Bam. So anyway, like I said, we canceled the 6 out. We eliminated it. We made it equal to nothing. And so we can just bring that x down. X is equal to 6. X is isolated. It tells you who he is or who he or she is. It tells you its value, okay? And that's it. So we had to do the opposite operation to group the 6 and the 12 together. And we wanted to bring the 6 over here to this side because x is already kind of almost by itself. If we could just get rid of that 6. Okay, let's do another one. And I know it's obvious, you guys probably could see that answer from the very beginning, but that's not the point. The point is to practice the steps, practice the procedure, right? What's my first step that I like to do? I like to draw the line. Just so I can be very clear about what side is which. All right. Or which side is which. I don't know. Anyway, so again, same thing. We want x isolated. We want x by itself. So out of the 3 terms that I have, which ones are the like terms? The like terms are the numbers that don't have letters with them. And again, just to repeat that, what I mean is it's not like this, right? These are different terms because this has an x and this doesn't have an x. All right? Go back to grouping and simplifying if that doesn't make sense. There's a video on that. All right, so I'm going to go ahead and leave x here on the left side of the line or the equal sign. And I want to move the 5 or group the 5 over to the 10. Now remember, when we're grouping, it's always going to be an addition or subtraction. Okay? That's it. It's always going to be that. So you just got to figure out what I got to do to the 5 to get to group it over there with the 10. Do I have to add or do I have to subtract? What sign does the 5 have? I know that all of you are saying, well, it's added, but this isn't the sign that we need to pay attention to, really. We need to pay attention to the sign that's to the left of the 5. That positive goes with the x. Okay, so the x is positive. That's how that works. So what sign does the 5 have? It's positive because it doesn't have a sign. Numbers that don't have signs are positive. The 10 is also positive because it's not explicitly written. Anyway, so what do I do to this positive 5 to make it equal to nothing? Opposite. Opposite. Subtraction. Okay? And that will be 0, or I can just cross it out. Okay? Now what I do to one side, I do to the other. What did I do to this side to get 0? This is what I did. That was my operation. I subtracted 5. All right, so we're going to do that same thing over here to the other side to maintain equilibrium or to maintain equal. All right, bring down my equal sign. I put it right there on the line so I know where it is. 10 minus 5 is 5. I'll bring down the 5. And the only thing that's left over here on this side, the 5's gone, so the x. X is equal to 5. Again, you guys could see this from the very beginning. 5 plus 5 is 10. So 5 plus something is 10. Well, that's got to be, it's got to be 5. But again, I'm not trying to get you guys to guess the answer just by looking at it. I want you to practice writing things down. Okay? All right, let's do a couple more. All right. What's another one I have here? I have this one. Okay. Again, I'm not going to talk so much this time. I have 3 terms. I want to group the 2 with the 8 to leave x by itself. To do that, I have to realize that the 2 is positive, so I just subtract. Opposite operation to both sides. This is what I did. I'm going to do the same thing over there to that side. So the 2 is eliminated, leaving me with x is equal to 6. Positive 6 if I want to write down the sign. Might be a good idea. Okay? It's not too bad, right? Do a couple more. Let's change it up a little bit here. I have my little cheat sheet. Okay, let's try that one, yeah. Okay. Remember how the signs work. Okay, we want to do the opposite of the sign. Because again, we're adding and subtracting. We're grouping like terms. I have a 6, a negative 6, and a positive 2 that can be grouped together because they're like terms. So the idea later on when we get into more complex problems is that we're going to be wanting to group together all the numbers that don't have x on one side and all the numbers that have x on the other side. So x is over here, numbers over there. Pennies over here, quarters over there. That's what we're doing, okay? So, and again, when we do the multi-step problems, that'll become more obvious. But right now, we're just trying to group all the numbers over there because we want to leave the x by itself or isolated. So, what do I do to negative 6 to get 0, to eliminate it? Here's my balance for this 6 to just boom, just be gone, right? What do? I add. I do the opposite operation. And this is what I did. This is what I got to do over there. I'm not going to add 2 to that side because I've seen that. I don't know. It's again, it's abstract. It's not, we like things more tangible, things that we can touch. But anyway, so negative 6 plus 6 is 0. It's like owing $6 and you have $6, you pay your debt, so you don't know anything, right? Okay. So what I do over here, plus 2 plus 6 is plus 8. And I'll just bring down my x because it's all by itself. X is equal to 8. So what we're saying here is negative 6 plus 8 is going to be equal to positive 2. All right? Cool, cool. I'll do one more, then I'll let you guys try a couple, okay? Let's see, what's a good one? Well, we'll be pretty direct here. Okay, what's first step? I like to put the line, that's just me. All right, so do we have to add or do we have to subtract in order to group the 3 and the 9 together? Remember, we have 3 terms. These 2 are like terms, and they should be grouped on one side of the equation, or the equal sign. Okay, so what do I do to 3, or negative 3 to equal 0? I add 3. Okay, bam, just like that. And x is going to be equal to 9 plus 3 is 12. Okay, can you guys all see that? Yeah, it's all there. Okay, so that's it. I mean, again, this video is only concentrating on addition and subtraction. Sometimes we have to add, sometimes we have to subtract. But all we're really doing is grouping terms together. Okay? So like I said, and like I usually do, and I don't know how many of you actually try it on your own, or if you guys just keep watching the video, but I will keep going through the motions. And I put these 2 problems up here for you to try. So the first one says, negative 7 is equal to minus 21, or negative 21 plus x. And this other problem says x minus 5 is equal to, I'm not sure if my equal signs are very clear, huh? Let's see here. Anyway, so x minus 5 is equal to negative 15. Pause the video, see if you get these answers. Okay, so how did it go? See, how many of you actually stopped the video? I wonder. Anyway, so I'll do, let's see. You know, I'll start with this bottom one here first. I can just write it right here on this board. X minus 5 minus 15. I have three terms, and out of these three terms, I should group the numbers on one side of the equal sign. And I'm pointing that way because I want to, x is already over here. And again, I want to isolate x. I want to get everything away from x. So, first step, my line. What do I do to 5 or negative 5 so that it equals 0? If you owe $5, what do you got to do so you don't know anything, right? So you owe 0. Well, you gotta pay your bill. You got to pay $5, okay? And I'll do the same operation to the other side. Remember, we're adding 5 to both sides. Okay? And this one eliminates completely. It's gone, equals 0. I can bring down my x. And then minus 15 plus 5 is actually going to be negative 10. Okay? If that's confusing, go back to the video where I explain that stuff. Adding and subtracting positive and negative numbers. Okay, so I'm going to go ahead and write, so you should have got negative 10. X is equal to negative 10, all right? I'm going to go ahead and rewrite this one on the board, on the bigger board. All right, so we had negative 7 is equal to negative 21. X plus, oops, sorry. We're not doing that yet. We're not doing that yet. That's video number 2. All right. That was the equation that we had. So first step I like to do is draw a line where my equal sign is, so I know where left and right is of the equal sign. Okay, so I have three terms. I should have done one where they had multiple terms, huh? It's the same thing. Anyway, so we're gonna subtract. I'm sorry. We're gonna add the 21 to the negative 7 so that we can group together the numbers on one side. Okay. In this video, we're trying to keep it simple in this one. Maybe later on I'll do more of a more complex one like that. Okay, so negative 21, you pay out 21, or you add 21, and you'll get 0. You'll owe nothing, right? I like to think about money again. I like money, I guess. I don't know. It seems like when we talk about money, everybody's like, oh yeah, I get it. I understand. It's like you're speaking my language. Okay, so what we did over here was add 21. We're going to add 21 to this side. All right, so minus 7 plus 21 is going to be equal to plus or positive 14. Okay? So again, I hope this helps you at least with these first basic problems. I don't want to call them simple, but I do want to say that they are basic. They're one-step problems to get to the answer. And remember, we're going to be doing more. Multiplication and division. We're going to start simple with one-step problems. And then later on, we're going to go on to bigger and more beautiful, complex problems. Okay? So, good luck, keep practicing, and see you on the next one.